Greetings, fellow coders! Today, we're diving into the world of functions and reusability. One of the main reasons we create functions is so they can be reused. Today, we'll be creating a function that we will use multiple times in a program to showcase that reusability. Then, we'll show how functions can work together by creating helper functions to further break down the steps of a larger problem. These concepts are essential for writing methods that keep our code organized and efficient. So, let's explore them together. Functions are like building blocks in our code, allowing us to encapsulate specific tasks or operations into reusable units. They help us break down complex problems into smaller, more manageable parts, making our code easier to understand and maintain. Reusability, on the other hand, is all about maximizing efficiency by using these functions multiple times throughout our program. To illustrate these concepts, let's create a program that calculates the price of space rocks based on their types and weights. Each type of space rock has a different value, and the total cost is determined by multiplying this value by the weight. In this example, we define a function called calculatePrice that takes two parameters, rock name and weight. Based on the provided rock name, the function determines the price per kilogram and then calculates the total cost by multiplying this price by the weight. Try creating this function in your guided notes now. Here is the code. Now that we have this function created, we can demonstrate its reusability by calculating the prices of different space rocks with varying weights. The calculatePrice function is called multiple times with different inputs. From this, we can easily determine the worth of each space rock. This example illustrates how functions and reusability go hand in hand, allowing us to write concise and modular code that can be reused across different parts of our program. By breaking down tasks into reusable functions and using them throughout our program, we can tackle complex problems with ease. In this example, we'll be assessing our solar panel arrays that we laid out on one of the planets we visited. Notice that all of the solar panels are squares, and we currently have an array of numbers that represent the length of one side of that square. Here is our array. We want to create a function that gets the area and the perimeter of each of these squares using the length of one side. Since we have multiple calculations that we have to perform multiple times, let's break down the problem into parts. First, we need a function to calculate the area. Let's define one now. Our getArea function will have one parameter named side length. We want to multiply the side length by itself, store it in a variable, and return it. Try writing this code yourself in your guided notes. We define the function getArea with side length as the parameter. In the function body, we multiply side length by side length and store that in a variable named area. Then we return the variable area. Now we need to create a second function that calculates the perimeter. Our getPerimeter function will have one parameter, again named side length. We want to multiply the side length by 4, store it in a variable, and return it. Try writing this code yourself in your guided notes. We define the function getPerimeter with side length as the parameter. In the function body, we multiply side length by 4 and store that in a variable named perimeter. Then we return the variable perimeter. By defining these helper functions, getArea and getPerimeter, we can easily reuse them whenever we need to perform similar calculations, making our code more efficient and maintainable. Now we'll build one final function named panel calculations that will demonstrate reusability by using these helper functions to calculate the area and perimeter of multiple solar panel squares, back to back. This function will iterate through an array of side lengths as seen here. Each value in the array represents the side length of a solar panel square. We'll use getArea and getPerimeter to calculate and print the area and perimeter of each panel. Here's how we can do it. We define our panel calculations function to accept a variable side lengths, which is our array of side length values. Next, we will need a for loop to go through each value in side lengths and store it in the temporary variable side length. Can you write this loop? Try it in your guided notes now. Your loop should look like this. Now we need to call getArea passing in the side length and store the results in a variable area. We'll do the same for our perimeter function. Can you write these calls? Try this one more time in your guided notes. Your code should look like this. We call the getArea function with side length as the parameter and store the return value in a variable named area. Then we do the same thing with our perimeter function. Now we can print out the area and perimeter like this. Great job! After all of that hard work coding the functions, we now get to see the functions in action. All we need to do is call our panel calculations function like this. Remember, our array looks like this. After calling that function, this is the output. All those numbers are confusing though. What could we do to our code to make it clearer which number is which result for which side length? Edit our print statements, of course. Let's add a few lines so that the print statements identify the side length, then introduce the area and perimeter before printing the values. If we add this code, our output will look like this. In this example, panel calculations leverages the getArea and getPerimeter functions to carry out its task. This is a clear demonstration of reusability. We write the logic for calculating the area and perimeter once and reuse it as needed, rather than repeating the same code over and over. By breaking down our problem into smaller functions, we've made our code more readable, maintainable, and flexible. Now let's jump into another musical task. All of these instruments we've been using have inspired me to sing. I would love to add a musical background to my singing. How can we match the notes I'm singing with the perfect accompanying music? Well, that's where our coding skills come in handy. We need to develop an intelligent algorithm that can analyze the difference between the notes I'm singing and a certain semitone. And to do that, we're going to compare the frequencies of my tone with the frequencies of the semitone. Here's the plan. We'll create a function called tone distance that takes two parameters, the semitone we're comparing against and the frequency of my tone. The semitone parameter will represent a certain pitch in music, and the frequency parameter will be the frequency of the note I'm singing. Inside our tone distance function, we'll use another function called getFrequency to obtain the frequency of the semitone we're comparing against. This function will return the frequency of any given semitone. Next, we'll calculate the difference in frequency between my tone and the semitone. This will give us valuable insights into how closely my singing matches the desired pitch. And voila! With our tone distance function, we'll be able to analyze the harmony between my spontaneous singing and the accompanying music, creating a seamless blend of melody and rhythm. We've now seen firsthand how breaking down complex problems into smaller, more manageable parts not only simplifies our code, but also enhances its efficiency and clarity. By harnessing the power of functions, we create building blocks that can be reused across various parts of our programs, saving us time and reducing the potential for errors. Our exploration began with understanding why functions are so crucial in programming, emphasizing their ability to be reused whenever needed. We explored a real world example calculating the price of space rocks, reusing the calculate price function whenever we needed a price for a new space rock. The creation and use of helper functions such as getArea and getPerimeter showcased how we can break large tasks down into smaller, more manageable pieces. By calling upon these helper functions within other parts of our program, like in the panel calculations function, we leveraged their functionality to solve complex problems with simplicity and efficiency. Understanding the power of functions and the importance of reusability will equip you with the skills needed to tackle challenges more effectively, write cleaner code, and become a more proficient programmer. Be sure to complete the programming tasks, practice questions, and extension activities before moving on to the next lesson. And remember, in the universe of coding, the possibilities are infinite. I'll see you next time.